something about the reactivity of different elements. Okay, of different elements. Now in the next chapter, that is chemical bonding, we are going to understand how these different elements, they interact with each other. When they form new compounds, then how do they interact with each other? So now till here we were looking at individual elements. Now here we are going to look at molecules and how are these molecules formed? What are the, if I have two elements and two atoms, how are these two atoms sticking together? How are these two atoms sticking together? We are going to talk about this in the chemical bonding chapter. Okay, in the chemical bonding chapter. So please write the chapter's name, chemical bond. And molecular structure. Chemical bond and molecular structure. Write the first statement, chemical bond. What is the chemical bond? Please write the attractive force which holds together the constituent particles in a chemical species is known as chemical bond. Is known as chemical bond. So first thing, chemical bond is an attractive force. Okay, and that is something that is going to be constant in all the definition of chemical bond. That is an attractive force which exists between two different atoms. Okay, and chemical bond, it exists in what? It exists in two different. It exists between two different atoms. Okay, it exists between two different atoms. That is a chemical bond, and chemical bond leads to formation of different molecules and compounds. Done, everyone? Yes, please tell me.
Yes, sir.
Right, next. Now, why do different elements they bond together? So one of the theories is, right, why do atoms combine? Why do atoms combine? So the early chemists who did not know much about different elements, they were very much limited elements present and they were doing reactions with those elements only. They came to a conclusion that chemical bond is formed between these, right? A chemical bond is formed between two combining atoms to gain stability by achieving the nearest noble gas configuration. Okay, but according to the modern concept, please write. According to modern concept, chemical bond is formed to gain stability by release of energy.
Right, sir.
Now, chemical bond, it can be classified into three main categories: ionic covalent and coordinate covalent bond. But there is a rule, that is octet rule. We have to understand that rule first. That is going to be very important. And again, octet rule is not valid for all of the elements, but it is valid till the second period elements. So please write octet rule. This explains the stability of many of the elements also. Walaikum salam, Fahad. Is right? Octet rule. The principle of attaining the principle of attaining maximum of 8 electrons in valence shell of atom is called octet rule. All right, next. You can classify chemical bond into 3 types. Please write chemical bond. This can be ionic. This can be covalent. This can be coordinate also. We'll explain each one of these one by one. So first of all, you will write the topic, ionic bond. This is also known as electrovalent bond. Please write the topic, ionic bond. Or electrovalent bond. Now, the ionic bond, it is formed by the transfer of electrons. So we'll please write here, the bond which is formed by transfer of electron between two combining species. Between two combining species or atoms, you can write, is called ionic bond. A very simple example of ionic bond will be the bond between sodium and chlorine. So in sodium, we have the electronic configuration is going to be, I'm just going to write the 9th class configuration, 2, 8, 1. So in the valence shell, we have only one electron. And in chlorine, if you see, it has 2, 8, 7. So it has how many electrons? It has 7 electrons. If I talk about the octet rule, then this sodium is going to have 1 electron like this. The chlorine is going to have 1, or rather we represent it like cross here. But first of all, I have to make the chlorine a bit a better way. Okay, fine. So I have 1, 2, 3, 4, 5, 6, 7 here. And the sodium help chlorine to attain the sodium will give 1 electron to chlorine. So now after the transfer of electron, what is going to happen? After the transfer of electron, sodium has lost electron. That is why sodium will get a sodium positive charge like this. And the chlorine is going to have chlorine 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Now this is also completely filled. Now since it has gained 1 electron, it will get a negative charge like this. It is going to get a negative charge. Sodium is going to get a positive charge. Now this positive ion and the negative ion, they're going to attract each other. And due to this attractive forces, they are going to form a bond. And this electrostatic attraction leads to ionic bond. This is an electrostatic attraction. Electrostatic attraction. Electrostatic attraction just means the attraction between two oppositely charged ions or particles. So it takes a transfer of electron. Okay, sodium is giving 1 electron to chlorine, and they are forming sodium plus and chlorine negative. Now, if you look at sodium, sodium is going to have a very low ionization enthalpy. That means it can leave the it can give electron, it can lose an electron quite easily. And if I look at chlorine, chlorine is going to have a very high negative value, of electron gain enthalpy. That means if it is gaining electron, it is going to release energy. Now this whole process is going to do what? This whole process is going to give a release of energy. It is going to release energy. And also you can see that any positive, if any positive now has an electronic configuration that is very similar to that of neon, 10 electrons. And if you look at chlorine here, chlorine is going to have a electronic configuration completely as that of argon, that is 18 electrons. But they have achieved the nearest noble gas configuration. Both of them are also having 8 electrons only. Okay, so this can be explained, the stability can be explained here by the octet rule also. But now, the condition for an ionic bond is that it should have a low ionization enthalpy, and it should have very high negative value of delta H, e.g. that is electron gain enthalpy. So please write conditions for formation of ionic bond. Condition for formation of ionic bond. Right, number 1. One atom should have low value of delta H, that is ionization enthalpy. Right, the second point, one atom should have high value of negative delta H, Eg. Right, the next point, now, once these two atoms are going to combine with each other, they should also release a abundant amount of energy. If they're not going to release abundant amount of energy, the attraction between them is not very strong. So the third point is, and we measure that by lattice energy. So write the third point. And we are going to expand on this point also. Please write lattice energy should be high. So these are the 3 points. These are the three conditions for the formation of ionic bond.
So,
Yeah, tell me.
so could you repeat what is lattice energy?
Lattice energy, we are going to expand. Okay, I'm going to write the concept of lattice energy after this point. When two atoms they combine with each other, when one mole of them combine with each other, when one mole of the molecules they make a solid ionic compound, whatever energy is released, that is known as lattice energy. Write these 3 points down. We will write about lattice energy completely, and also how to determine the relative lattice energies of two different molecules, how to compare the lattice energy of two different molecules also.
Done, sir.
Right, next, concept of lattice energy. Now there is a definition of lattice energy and there is a method of determining the lattice energy. Okay, so see how it is defined. Please write the amount of energy. The amount of energy released in the formation of released in the formation of one mole of solid, rather 1 mole of ionic solid, we should write 1 mole of ionic solid from gaseous ions is called lattice energy. It's called lattice energy. Now, this is the definition of lattice energy, but again, it's quite difficult to measure how much energy is released when 1 mole of ionic solid is formed. So, better what we do in terms of measurements, in terms of measuring the lattice energy, we take 1 mole of ionic solid and we break it completely and we turn it into the gaseous atoms. Okay, the gases, the constituents, gases, elements, or atoms. And whatever energy is required to break that 1 mole of ionic solid, we say that that is the lattice energy. That is the lattice energy. So please write the amount of energy required to break 1 mole of solid, 1 mole of ionic solid, 1 mole of ionic solid into its constituent gaseous atom is called lattice energy. Now, if the ionic bond between the two combining atoms, it is very strong. If the attractive forces is very high, that means it is going to take a lot of energy to break it. That means the lattice energy will be high. So we can also say that lattice energy, it represents the attractive force between the combining atoms. If we have two ions, cation and anion, they have attractive force that if the attractive force is very high, it will require a high amount of energy to break that 1 mole of ionic solid. That is why we'll say that the lattice energy is high for that. Okay, so right next. Write it as a note. Lattice energy represents the attractive force. Lattice energy represents the attractive force present between the two oppositely charged ions forming an ionic solid. At the next point, lattice energy will have negative value. Higher the magnitude of lattice energy, stronger will be the ionic bond. Stronger will be the ionic bond.
Sir, why negative value?
Because the energy is releasing here. Lattice energy, as per definition, it is what the amount of this. This is the definition of lattice energy. The first thing that we have written, okay. And the next thing that we have written, that is how we are going to measure it, measurement thing. So as per definition, energy is released. So whenever energy is released, that is going to be negative in the form. Okay, so even if you can see, a very classic example of release of energy is, let us suppose we have some pen at 1 meter height. So potential energy is equal to how much? Tell me. It will be something, let us say mgh, right? It will be mg, right? The potential energy, whatever the mass is, into the gravitational force. But when it reaches the ground, the same thing, it reaches the ground, then in this case, the potential energy, it is going to be how much? It is only going to be 0. So if it is falling down, if it is going from 1 meter height to 0, then what is happening? So we'll see that final minus initial. Final is 0, initial is mg, which is equal to negative of its mass into gravitation, right? G. So this is going to be a negative value, right? This is going to be a negative value. And what is happening here? It is releasing energy. It was having some energy mg, now it is having 0 energy. So where has that energy gone? It has released that energy in the form of kinetic energy. Okay. So whenever there is a release of energy, that release of energy will always have a negative value. And what I have written, higher the magnitude of lattice energy. That means you don't have to look at the sign here. I'm talking only about the magnitude. If the magnitude of lattice energy is high, for example, it is, if I compare two lattice energies, for example, it is minus 293 kilojoule per mole and one is minus 300 kilojoule per mole. Then this minus 300 one is what? It is stronger ionic bond. It is stronger ionic bond. Okay, so you have to look at the magnitude when we are comparing it. Negative sign just means that it is releasing energy. You got it, Devangi? Yes or no? Tell me.
Yes, sir.
Please keep this framework in your head, okay, about release of energy, falling down of a pen or something, some brick type of thing. It will have potential energy in the initial stage, but at the final stage, it will not have any potential energy. That means it is releasing energy. And whenever there is a release in energy, that sign, that change will be negative. Okay. Now, let us understand the factors affecting lattice energy. I will take 2 examples, and from those 2 examples, I'm going to conclude a few things. Let us suppose we have here charge. Let us say here we have 2 plus charge, and we have some ion. This ion is having 2 negative charge. And in the other case, now I have drawn the cation as large, cation as smaller and anion as larger. Okay, as it should be. Now we have 2 other molecules. It has only 1 charge and it has 1 negative charge. Obviously, the ionic compound, which is having more charges, they are going to attract each other more effectively. And I can say that this will have higher lattice energy. That means breaking of this particular ionic bond, it is going to take me more energy. I hope this is very clear. It is very logical that more charges, they will attract themselves more effectively. The attractive forces will be high. Now there is another concept. So let us suppose we have the same things. Let me take this one. We have this one case here like this, and the other case is something like this. Okay. Now, all of you must know that positive charge, it resides in the nucleus. Positive charge, it resides in the nucleus. So I will say that it has one positive charge, it will be in the nucleus. And the negative charge in the anion, it is due to the electron. So negative charge is somewhere here in the valence electron. Okay, in the valence electron, it is somewhere. We can also say that it is here. Okay, so the positive and negative, they are interacting here, and it is having what distance? You can look at the distance here. And what is the distance here? If I say, let us suppose that the negative charge is here, then the positive, that means the nucleus and the negative charge, they are very close to each other. Now here you can say that as the distance increases, the attractive forces will decrease, because when positive and negative charges are near, they are going to have more attractive forces. The attractive force decrease as we increase the distance between them. So obviously there are two factors. First one is charge, the other one is the size of atom. So if the size of atom is going to increase, the distance between positive and negative charge is also going to increase, and that will lead to a decrease in the attractive forces. So here the lattice energy of the first case will be higher. Is this clear to everyone? Yes or no? Please tell me, guys, about the charge and the size of ions.
Yes, sir.
Okay. Right, next, factors affecting. Lattice energy. The first factor is magnitude of charge. By the way, let me tell you that electrostatic force of attraction, you will learn this in your 12th standard in physics class, that gravitational force, it is defined as what? G into m1 m2 upon r square. Electrostatic force of attraction between two opposite charge, it is defined as, there is some k constant such as g, then you have q1 into q2. These are the quantities of charge. Q1 will be positive and the Q2 will be negative. But again, it is not going to be, you can write there oppositely charge also, but here it is going to be r square. Okay, so you can see that F is directly proportional to the product of the charges, and it is inversely proportional to the distance between them. Okay, the first is magnitude of charge. Magnitude of charge. Here lattice enthalpy. I'm also again talking about the magnitude of lattice enthalpy. Okay? It is directly proportional to Q1 into Q2. Okay, Q1 into Q2, whatever the charges of the cation and anion is. Second is the size of ion. For size of ion, you will write lattice enthalpy. It is inversely proportional to size of ions. So first of all, we will always compare the magnitude of charge. Okay, so magnitude of charge is going to be always a dominating force here. But when the magnitude of the charges are same, and then you are going to compare the size. Write some examples. If I'm going to compare between magnesium oxide and lithium chloride, in this case, what is magnesium oxide? Magnesium oxide will have Mg2 plus and O2 negative. Lithium will have, because Mg is in the second group has a valency of 2, it is going to lose 2 electrons. Oxygen is in 16th group, it is going to gain 2 electrons. Here we are having lithium positive and chlorine negative. So if you calculate the Q1, Q2, so it is 2 into 2. You just have to take the magnitude, okay? 2 into 2, which is equal to how much? 4. Here it is 1 into 1. which is equal to 1. So again, and now since we have got the answer just with the magnitude of charge, we don't need to look for the sign. So it is going to be MgO will have higher lattice enthalpy than lithium chloride. Right, next. For example, you have lithium chloride versus sodium chloride. If you look here, then the Q1, Q2 is going to be same for both the cases. Lithium is also +1, chlorine is +1, sodium is also +1. So Q1, Q2 is 1 into 1. Here also it is 1 into 1. Both of them are equal to 1. Both of them are equal to 1. Now we have to look for the size. Now we can say that, see, chlorine and chlorine both are same here. So we don't need to compare chlorine and chlorine. We just need to compare the size of the cation, that is lithium and sodium. If I look at the size of lithium and sodium, you should remember that it is in the first group and we have the sequence as Lena-Krupp-Kasper. We have the sequence as Lena-Krupp-Kasper. Now in this sequence, we can say that lithium is having smaller size. So I will say lithium is having smaller size than sodium. And that is why lattice enthalpy will be what? Lattice enthalpy is inversely proportional. So you will just switch the sides. Lithium. So you will write it like this. Wait a second. Lithium chloride will have higher lattice enthalpy than sodium chloride because these are inversely proportional. And the third case, please write if you have calcium fluoride, CaF2 versus CaCl2. If I look at the charges here, then calcium is going to have Ca2 plus. Now fluorine is going to have, there will be two fluorine negative, F negative ions. There will be two F negative ions. Here also we will be having calcium 2 plus, and there will be what? Two chloride ions, that means two Cl negative ions. Now Q1, Q2, the cation charge is 2, and also anion is how much anion is? There are two anions with one negative charge. Here also 2 into 2 in bracket 1. So 1 represents that charge on the individual anion and 2 represents the number of anions that we have. So Q1, Q2 is again same here, 4 in calcium fluoride and 4 in calcium chloride also. Now we have to look at the size. Now since the calcium is same here, we don't have to compare calcium. We just need to compare the sizes of fluorine. So here we can say that fluorine is going to have a smaller size than chlorine. And that is why the lattice enthalpy will be inverse of that. So we have CaF2. It will be having higher lattice enthalpy than calcium chloride, CaCl2. Now write a question. Which of the following pairs forms the most stable ionic bond? The options are Na plus and chlorine negative. B is Mg2 plus and fluorine negative. C is lithium positive and fluorine negative. And the D option is sodium positive and fluorine negative. If you look at all of these options, A, C, and D, all of them are having +1 and +1 charges. Mg2F will form a molecule which is MgF2 because Mg and fluorine. So Mg has a valency of 2, fluorine has a valency of 1. So they will make a compound that is MgF2. Now here Mg is going to having +2 and fluorine is also going to have 2 into 1. That is equal to how much Q1, Q2? 4. Now this is going to be greater than anyone else. That is why the B option is the correct option here. Mg2 plus and fluorine negative are going to make the most stable ionic bond. So these type of questions are also asked in, like this was asked in AI-PMT. AI-PMT is the older version of NEET examination. Done everyone? Yes or no? Please tell me.
Yes, sir.
Right, next covalent bond. Writing this. The second one, that is covalent bond. Okay, right. The bond which is formed by equal sharing of electron between two combining atoms is called covalent bond. It's called covalent bond. Write the conditions for covalent bond. Okay, right here. Number one is both atoms should be predominantly non-metal. The next point, electronegative difference. Electronegative difference should not be high or should not be large. Done, guys? Yes or no? Please tell me about the conditions.
Yes, sir.
Right, next types of covalent bond. Right, next types of covalent bond. Number one is non-polar covalent bond. Okay, what is non-polar covalent bond? When we have bond between two same element. Okay, for example, hydrogen makes a bond with hydrogen, fluorine makes a bond with fluorine, chlorine makes a bond with chlorine. So all of these type of bonds will be what? These will be non-polar covalent bond. Please write the covalent bond. The covalent bond formed between atoms of between atoms, rather right between two atoms of same element, two atoms of same element, then the bond is called or known as non-polar bond. For example, hydrogen making a bond with hydrogen, chlorine making a bond with chlorine, bromine making a bond with bromine, oxygen making double bond with oxygen, nitrogen's making a triple bond with nitrogen. All of these are examples of what? Non-polar bond. The next one is polar covalent bond. Now, whenever the molecules, whenever bond is made between two different atoms, different atom will have different electronegativity. If there is different electronegativity, one of the atom is going to pull the electron. If one of the atom is going to pull the electron, the atom pulling electron will get a partial negative charge because the electrons will be towards, or electron will be nearer to that particular more electronegative atom. So it will be delta. It will have a delta negative charge, partial negative charge, little negative charge, and the other atom is going to have a partial positive charge. That is going to lead to a polarity here. So please write if the, or rather the covalent bond formed between atoms of two different elements, then the bond is called polar bond. Then the bond is called polar bond. For example, you have hydrogen and fluorine. You have a molecule HS. Now here, fluorine is more electronegative. Now, since it is more electronegative, it is pull the electron towards itself. When it is pulling the electron towards itself, it will get a delta negative charge, some partial negative charge, and hydrogen is going to get a partial positive charge. Now, this is known as a polarity. This is known as a dipole. So we have two poles, positive and negative. Even though they are sharing electrons, it is not complete positive or complete negative. That will make it ionic. It is not complete positive and not complete negative, but it is partial positive and partial negative charge on hydrogen and fluorine respectively. It is creating what? A partial positive. That means it is one pole. Pole means what? Two different opposite sides, right? Polarity, dipole. Two different poles, positive and negative. So it is also making a dipole moment here, something like this. It is known as dipole. It is representing the positive and this is representing the negative. So you don't have to worry about that. You just need to know that it is what? It is polar. You have a delta negative here and delta positive here. The more electronegative element is going to get delta negative. The lesser electronegative element or electropositive element is going to get a delta positive. So for example, you have HCl. Here this will be having delta negative. This will be having delta positive because chlorine is more electronegative. If I see the hydrogen, water molecule, this will have hydrogen. Then it will have, you will understand the shape later on, but this is the shape of water molecule. Oxygen is going to have a delta negative because it is going to pull electron from both the hydrogens. This hydrogen is delta positive. This hydrogen is also delta positive.
Sir,
Tell me.
sir, if the electronegative difference is very high, then it will not form covalent bond.
No, it is forming covalent. If both of them are non-metal, then it is going to form a covalent bond only. But if one of them is metal and the other one is non-metal, then it is going to form an ionic bond. Okay. What did you ask, Devangi? If they are having large difference, then it is not going to form. No, they are going to form covalent bond, but that covalent bond will be polar covalent bond. Got it?
Okay, sir.
In what? Yes, Devangi, what were you saying?
Sir, I understood.
Acha. Right, next, coordinate covalent bond or dative bond. Third category. It is also known as semi-polar bond, but not very much right nowadays. It is mostly known as coordinate bond. It is right here, a special type of covalent bond. Special type of covalent bond in which one-sided sharing of electron takes place between two combining atoms. So for example, we have something like this. We have here A. A is having all of its 8 valence electron. But B has only 6 electrons in its valence shell. In its valence shell, it has only 6 electrons. Then what A is going to do? A is going to not give the electrons to B. Because if A is going to give the electrons to B, then it is going to be what? Then it is going to be 6 electrons. A is going to have 6 electrons. So what the optimal case will be? Optimal case will be that A and B, both of them share the electrons of A only. So let me represent it like this. The A electrons are in red and B is in blue. B is in blue. So if they are forming a bond, they are forming a bond like this. We have here A forming a bond with B, but all the electrons in the bond are of A. Now you can see that A has 1, 2, 3, 4, 5, 6, 7, 8 electrons due to that bond, and B has its own 6 electron. Now it is unequal sharing. It is different. Now it is sharing, that is why it is covalent. But it is sharing by only, there is a sharing with by only one of the atoms. Only A is sharing. B is not sharing anything, right? Only A is sharing the electrons. For example, this A has the A has scale and pencil. Okay, and B has nothing. So what is A doing? A is giving. So A and B both are sharing the scale and pencil of what? The A boy only. Okay, so they are sharing the scale and pencil of A. But in the case of covalent bond, A and B, A comes up with scale, B comes up with pencil. Now A and B are sharing scale and pencil, both of these things. So can you understand the difference between covalent bond and the coordinate covalent bond? Yes or no? Tell me. In the coordinate, this is covalent. Okay, this is covalent. Each one of them is sharing something. Each one of them is coming up with something. This is covalent. Okay. So A is giving scale to B, B is also giving pencil, and both of them are sharing this scale and pencil. This is covalent. But if only A is bringing the scale and pencil, B has nothing, then it is going to be what? It is going to be coordinate bond. Please write this down. Let me know when you're done, guys.
Done, sir.
Is everyone done?
Sir, I didn't understand.
Sorry,
Sir, I didn't understand.
क्या बोल रहे थे? आवाज नहीं आ रही आपकी.
Sir, समझ नहीं आया ये वाला.
Which part? Tell me.
Sir, this one. Covalent
Coordinate bond.
coordinate differences.
Okay, so in coordinate covalent, what happens in covalent bond file? What defines a covalent bond? Sorry?
Covalent bond
In covalent bond,
shared by two one.
electrons are shared, right? In covalent bond, if A and B are there, then both of them will be bringing up one electron. Got it?
Yes. Yes.
Okay, A and B, both of them are bringing electrons. But when we take the case of coordinate bond, then the electron pair that is present in the bond, that is completely of one of the atoms, A. That type of sharing is known as coordinate covalent bond.
Sir, can you give an example for coordinate bond?
I can give an example. For example, you can write, you have NH3, which has a lone pair here like this, and we have BF3. If you look at BF3, NH3 has one lone pair, BF3 has only 3 bonds. Each bond will have how many electrons? It will have 2 electrons. Both of them react and they form the nitrogen's lone pair. It is directed towards boron atom. Boron atom is having now 3 bonds from fluorine, and it has the hydrogen atoms like this. So this bond here between NH3 and BF3, it is going to be coordinate covalent bond. Okay, so the bond, it looked like this: nitrogen, bromine, hydrogen, 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 fluorine, fluorine, fluorine. So this bond is coordinate bond. Right next, let me know if you're not done, by the way. Right next, Lewis dot structure. Like, I will write Lewis dot structure sometimes as LDS. Also write that in bracket. Please write first of all. Lewis dot structure is composed of Lewis dot symbols of atoms or ions. First of all, we'll start with simple atoms or ions, and then we are going to move on to molecules also. For example, if I have to give the Lewis dot structure of Mg, then we will give the structure as Mg and give its 2 electrons like this. Or Mg and its valence electron like this. Okay, instead of dot, you can also use the cross sign. Both are valid. But what you have to see, what are these two dots representing? These two dots are representing the valence electron. And you have to know the valence electron of each and every element of the periodic table. You should know the periodic table also. Okay, so Mg has two valence electrons, so that is why I'm showing two dots or two crosses. But both of them, I mean, the structure should be symmetrical. Okay, so if you have writing something like this, it is fine. Most of the people will not deduct marks here like this, but it's not right to write the structure like this. These dots should be in a symmetrical position. For example, if I have sodium, then sodium has only one electron in its valence shell. That is why I will write sodium like this, or I can write it like this, or I can write it like this. Anyways, fine. Okay, there is no issue in any case here. Write the C1. For example, we have boron atom. The boron has 3 valence electrons. So I can write this as this boron, or you can also write it as this. See that it should be symmetrical. Write D. The case of sulfur. Sulfur is going to have 6 valence electrons. So you have to represent not the valency, but the valence electron. Sulfur, for sulfur, you are going to represent it like this. 1, 2, 3, 4, 5, and 6. Okay, so this is the better way of representing it like this. Right, E. If you have sulfur 2 negative, now it has 2 extra electrons. So we had how many electrons? We had 6 electrons. Now we have to add 8 electrons. So add it symmetrically on the 4 different sides, like 1, 2, 3, 4, 5, 6, 7, 8. And this is now going to have a negative charge. So we show the negative charge like this in square brackets. 2 negative. Write some more examples. For lithium positive, now since lithium positive will not have, it has no electron in its valence shell right now. That is, I will just represent it as lithium positive. You can write for nitrogen, which has 5 electrons in its valence shell. Nitrogen, 1, 2 electron here, 3, 4, and 5. Symmetry. Write this down. Let me know when you're done. So in Lewis dot structure, we have seen, first of all, the Lewis dot structure of different atoms and ions. Okay. Now we have to draw the Lewis dot structure of different molecules. Right, next for molecules. Lewis dot structure for molecules. The most important thing in Lewis dot structure is that you have to keep in mind that Lewis structure is very limited, and it is very limited and it is directly applicable for the molecules of second period only. We can, but there are, you can draw the Lewis dot structure of elements after the second period also, but for those structures you have to know the structure already. Okay, you have to know how the complete configuration is, where are the bonds and where are not the bonds. You have to know each and everything, then only you can make the Lewis dot structure. But for second period element, you can deduce the structure using the method. You can deduce the structure using this method. So basically what we have to do, the most important thing is you have to remember, you have to make each atom happy. Make each atom happy. That means it's composed of two things. That means there should be 8 electrons in the valence shell of each atom. Whatever atom you are going to have in a molecule, 8 electrons in valence shell of all atoms except hydrogen, because hydrogen can have only 2 electrons, as it can hold only 2 electrons. So for hydrogen, we will see that hydrogen should have at least 2 electrons in the valence shell. It should have 2 electrons in the valence shell. Okay. There are a few steps to draw Lewis dot structure. The first step is to determine the total valence electron. You have to determine total valence electron. Then in the second step, we have to draw a skeleton. In skeleton, we will have only single bonds. There will be no double bonds. In skeleton, we just draw the skeleton using single bonds. And the step 3, what we have to do, we have total valence electron. All the valence electron will either be acting as a lone pair electron or it will be acting as a bonded pair electron. Okay, so draw a skeleton. The next is add electron to complete octet. So you can remember this thing as this is TWE, TWE, this is S, and this is 8. Okay, so remember this for Lewis dot structure, TWES 8. Okay, if you can do this TWES 8, then it is very good. So first of all, we will practice a few things. We will first of all practice the calculation of total valence electron. Please write a question. Calculate the total valence electron in following. Calculate the total valence electron in following. Number A, carbon dioxide. I'm doing this for you. For carbon dioxide, we will have 4 electrons. Plus we have 2 oxygen atoms. Each of the oxygen atom has 6 electrons. And if you calculate the total, it is going to be 6 to the 12 plus 4, that is 16 electrons. Right, for the next one, NH3. H2O. We have CO3 2 negative. Now for this one also, I think you can write what is the valence electron for carbon, you can write here, plus 3 into what is the valence electron of oxygen, you can write here, plus there are 2 negative charge, that means there are 2 extra electron here. So this 2 negative charge, that means we have plus 2, and you can add it. Okay, so you have to write the valence electron of carbon here, valence electron of oxygen here, and then you can write the total valence electron. Also write E part, NO2 negative. So what is going to be the valence electron for all of these things? Please write this down. Send the answer on my WhatsApp. Fahad, recheck the last one. Recheck the last one, Fahad.
So 18. Sorry, I didn't check.
So nitrogen is going to have 5. Hydrogen is going to have 3. That is going to give you 8 electrons. Hydrogen is going to have 6. And no, hydrogen is not going to have 6. Sorry. Hydrogen is going to have there are 2 hydrogens, 1 in each hydrogen, plus 6 in oxygen. It is going to give you 8 electrons. Carbon has 4, oxygen has 6, 6, 3 is 18, 24 electrons. In O2 negative, it has 5 plus 2 into 6, because there are 2 oxygen, 6 in each, plus 1 electron that is in the negative charge. This is going to give you 18 electrons. Now, next, right? Skeleton. So we have seen how to determine the total valence electron. This is the first step that we are going to do for each Lewis dot structure. Okay, now right next for the skeleton. Now skeleton, the main important part is the choice of central atom. Choice of central atom. So please write the topic. Choice of central atom. Now, a few rule of thumb will help you to get the central atom. The first rule is that hydrogen and fluorine will never be central atom. Will never be central atom. Next rule is the less electronegative, atom is central atom. Less electronegative atom, then you have to remember the electronegativity series. So electronegativity series, you will remember it like this. The highest is fluorine. That is why it is never central atom. And you have oxygen, nitrogen, then you have chlorine, then you have bromine, iodine, sulfur, carbon, phosphorus, and hydrogen. Okay, so you can remember it like this. This whole thing you can remember as phone. You can remember this as call, or phone, call, or call, anything. You can remember this as bro. This whole part can be remembered as ishq. Then P for pyar. Hai, that's it. Phone call, bro, ishq pyar. Okay, so next thing we are going to draw some of the skeleton. Please write a question. Draw the skeleton for following. Draw the skeleton for following. A part. For example, we have carbon dioxide. So tell me which is going to be the central atom, carbon or oxygen, because we have only 2 atoms here. Which is going to be central atom, carbon or oxygen? Which is less electronegative? Look at that. नहीं आ रहा किसी को? Carbon, right? Carbon is less electron. That is going to be the central atom. Then we have 2 oxygen. तो उसको बिल्कुल symmetrically आप ऐसे लिख सकते हैं. This is the skeleton of CO2. Skeleton. अभी तक स्ट्रक्चर नहीं आया प्लीज, ठीक है? स्टेप बाय स्टेप जा रहे हैं हम. What is it? This is your skeleton. That's it. Now, each of these bonds that we have made, each bond is made by 2 electrons. Similarly, if I have, for example, a simple molecule of NH3, what is going to be the central atom here? Please tell me, guys.
Nitrogen.
नहीं, हाइड्रोजन और फ्लोरीन कभी नहीं हो सकता ना, उसको ध्यान में रखिएगा हमेशा, राइट? हाइड्रोजन फ्लोरीन कैन नेवर बी द सेंट्रल एटम, ओके? बिकॉज हाइड्रोजन तो एक ही बॉन्ड बनाता है ना, तो सेंटर में कैसे आ सकता है? दैट इज द रीजन वी डोंट पुट, सॉरी,
नाइट्रोजन
nitrogen is going to be the central atom, and you will just draw the hydrogen like this symmetrically. ठीक है? This is not the structure still I'm saying, this is just the skeleton. एक step बाकी है electrons को add करने का, ठीक है? B, and then for C, draw for H2O, and you can also draw for NO2 negative. Okay, so when you have negative charge and all, you don't need to worry about anything. You just need to draw the skeleton. So skeleton में सिर्फ और सिर्फ atoms आते हैं, आपको उसमें charge का कोई मतलब झंझट ही नहीं है. So nitrogen symmetrically, आप देख nitrogen का क्या है? Electron, it is less electronegative, and that is going to be the central atom here. Okay, so this is the skeleton. For water, please draw. Draw for water. Also draw for CO3 2 negative.
done.
Done. So you must. Sorry. ये ज्यादा आपके पास पढ़ रहे हैं क्या?
जी.
अच्छा. So hydrogen, oxygen, and hydrogen like this. Similarly for CO3, it will be carbon with 3 oxygens like this. Okay. Now, most important point, please note it down here. Otherwise, people generally forget. Each bond is made by using two electrons from the total valence electron. Okay. So if we have made that means we have used the 6 electrons of total valence electron. Okay, that means we have used the 6 electrons from total valence electron. Clear?
Okay. Yes.
Okay, fine. Next is what we have to do, add the electron to complete octet. So last step is what? Complete the octets of each electron. Or are we writing this in blue? Complete the octets. Okay, so I will start with the structure that is molecule CO2. So for CO2, what is the 2A? Tell me. Total valence electron is equal to how much, Fahad?
16.
16 electrons, yeah. Okay, then this is the first step. Second step में हम लोगों ने क्या बनाया इसका? Skeleton. अब बना लीजिएगा ऐसे oxygen, carbon and oxygen. ठीक है? Okay, till here?
Yes.
Okay. Now we have to add the electrons. We have add the electron. So what we have, total valence electron is there. How much? 16. And how much we have used in the skeleton? Tell me. कितने bond बनाए हमने? How many bonds did we make in the skeleton?
2.
2 bonds. That means how many electrons we have used?
4.
4 electrons we have used, right? So remaining is how much? How much is remaining?
12.
12 electrons is remaining. So we have 12 electrons, and in those 12 electrons, we have to complete the octet here. We have to complete the octet. Okay, we have to complete the octet. Now you see here, how can I complete? So see, now carbon has how many electrons? Now till now carbon has 1, 2, 3, 4, because you know that this bonded electron, these are shared between oxygen and carbon. So I can say that carbon now has 4 electrons. Yes? Can you see that? Yes or no? Please tell me. Tell me. How many electrons does carbon have?
In the valence shell.
No, नहीं, अभी यहाँ पे स्केलेटन में बताइए आप। स्केलेटन में देखिए वैलेंस शेल में जो उसके इलेक्ट्रॉन्स है ना, वो कौन कौन से हैं? ये बॉन्ड की वजह से जो भी होंगे, करेक्ट?
जी।
Each bond has how many electrons? Each bond has 2 electrons, right? Correct?
Yes.
Now these electrons are shared by carbon and oxygen both,
Yes.
right? That means carbon right now has how many electrons? 4 electrons, है ना?
Yes.
अच्छा, इस ऑक्सीजन के पास कितने इलेक्ट्रॉन है अभी?
4.
4 नहीं है ना, 2 ही है, देखिए ध्यान से।
अच्छा।
ठीक है, यहाँ पे कितने इस ऑक्सीजन के पास?
2.
2 इलेक्ट्रॉन है, ठीक है। नाउ व्हाट वी हैव टू सी, व्हाट वी हैव टू डू, वी हैव टू गेट ऑल ऑफ देम टू 8। ठीक है, हम लोग को सबको क्या करना, 8 देना। अच्छा, यहाँ पे बहुत आसान, हम लोग क्या करते, सबसे पहले आप क्या कीजिए, जो भी सराउंडिंग एटम्स है, ये तो कार्बन आपका सेंट्रल एटम है, सराउंडिंग एटम्स को आप इलेक्ट्रॉन दीजिए। ठीक है, सो विल गिव द इलेक्ट्रॉन्स लाइक दिस, 1 2 3 4 5 6, 12 थे, है ना, तो 6 हो गए, 6 7 8 9 10 11 12। नाउ बोथ द ऑक्सीजन्स आर हैप्पी, यस और नो, प्लीज टेल मी।
Yes.
ऑक्सीजन खुश है, कार्बन खुश है, बताइए।
Yeah.
कार्बन तो खुश नहीं है, क्यों खुश नहीं है? देखिए यहाँ पे ऑक्सीजन के पास कितने हैं? ऑक्सीजन हैज 8 इलेक्ट्रॉन्स, दिस ऑक्सीजन आल्सो हैज 8 इलेक्ट्रॉन्स, बट दिस कार्बन हैज ओनली 4 इलेक्ट्रॉन्स। सही है,
Yes.
राइट? नाउ इन ऑर्डर टू get all of them to 8, what these are going to do, see here. Now once you have done this, now since carbon is not happy, what we can do, this oxygen can share its 2 electron, this oxygen can share its 2 electron. I'm not sharing give, I'm not telling give, it is going to share. So now we are going to have oxygen with its 4 lone pairs, because it initially had 3 lone pair, now it will have only 2. That means it will have 4 non-bonding electrons, and it is going to have a double bond with carbon like this, and a double bond with carbon like this, with of the other oxygen. Okay, now first of all, what you have to do, you have to make the skeleton, give whatever electrons are there na to the surrounding atoms, and then see ki happy hai ya nahi happy, khush hai ya nahi khush hai. If someone is not khush, then what you have to do, you just have to share the electrons from surrounding atom to central atom, as we have done right now. Now you can see that carbon is making 1 2 3 4 electrons, 5 6 7 8 electrons. Now if you look at oxygen also, oxygen has 1 2 3 4 5 6 7 8. Similarly here also 1 2 3 4 in the non-bonding and 4 in the bonding electrons. Can you see that there 8
Yes.
electrons here, there is 8 electron here, there is 8 electron here. Okay,
Yes. So sir, the electrons are added. In
क्या
the,
मतलब? सॉरी अब थोड़ा सा ठीक से बोलिए, आवाज बहुत अजीब से आ रही है आपकी।
so the electrons are added in the outer, क्या बोलते हैं?
वैलेंस शेल, वैलेंस शेल।
नहीं, ऑक्सीजन में ऐड होंगे ना, कार्बन में नहीं ऐड करें।
हाँ, स्केलेटन के बाद आप कहाँ, ऑक्सीजन नहीं, सराउंडिंग एटम में ऐड कीजिए।
सराउंडिंग एटम्स।
ठीक है, सराउंडिंग एटम में ऐड कीजिएगा, फिर पूछिएगा कौन खुश नहीं। जनरली क्या होगा, आपको मिलेगा कि जो बीच में एटम आ रहा है वो खुश नहीं है, तो फिर आप क्या कीजिएगा, सराउंडिंग एटम से उसको शेयर करा दीजिएगा। ओके,
यस।
अब लेकिन अब देखिए, अगर आपके पास ना यहाँ पे और इलेक्ट्रॉन बच रहे होते तो फिर आप कार्बन को देते, क्योंकि एक को 8 से ज्यादा आप नहीं दीजिएगा। ठीक है, अब स्टार्ट कीजिए, जैसे आपके पास मान लीजिए यहाँ पे सिर्फ 10 इलेक्ट्रॉन होते ना, एक ऑक्सीजन को आप कितने देते, एक ऑक्सीजन को आप देते थे पूरे के पूरे 8, फिर उसके बाद यहाँ पे जितना बचता उसको देते। ठीक है, इक्वल डिस्ट्रीब्यूशन भी जरूरी नहीं है यहाँ पे। यू स्टार्ट विथ वन ऑफ द सराउंडिंग एटम, कंप्लीट इट, टोटल 8 इलेक्ट्रॉन दे दीजिए, अगले सराउंडिंग एटम के जितने भी आपके पास इलेक्ट्रॉन बच रहे उस एटम को दीजिए, उसके बाद अगर कुछ बच रहा है तो फिर उसको सेंट्रल एटम के पास दीजिएगा। सारे एग्जांपल्स करेंगे, अभी लिखिए इसको। Okay, so there are few things that you can draw some conclusions from here. You can talk about how many bond pairs are there. Bond pairs are how many? 4 bond pair electrons are there, right? There are 4 bonds, yes or no?
Yes.
And then there are lone pairs. Lone pairs means the electron which are not taking part in bonding. So you can see that each oxygen has 2 lone pair. देखिए ये pair है, ठीक है। आपके पास कितने आंख हैं? 1 या 2? फहद, आंख कितने हैं? How many eyes? How many eyes, Fahad? 2. On how many pair of eyes?
1.
हाँ ठीक है, तो लोन पेयर कितने हैं हमारे पास यहाँ पे? लोन
Four.
पेयर्स आर 4, बट द नॉन बॉन्डिंग इलेक्ट्रॉन्स व्हिच वी से नॉन बॉन्डेड इलेक्ट्रॉन्स इज इक्वल टू 8। फर्क समझ में आ रहा है सब में?
जी सर। सर एक्चुअली ना मेरा तो के बाद एग्जाम स्टार्ट होंगे नए स्कूल।
क्या होगा?
एग्जाम स्टार्ट हो रहे हैं नए स्कूल में आफ्टर
कब
2
से? आफ्टर 2 वीक्स। अच्छा, क्या क्या चैप्टर आ रहा है आपके इसमें स्कूल में?
1 2 3 and 4।
केमिकल बॉन्डिंग भी आ रहा है?
यस।
हम्म, स्कूल में क्या चल रहा है आपके? अभी केमिकल बॉन्डिंग चल रहा है?
जी।
अच्छा, वैसे ही करेंगे, क्या बोलते हैं, आप उधर से पढ़ते रहिए, संडे संडे हम आपको कुछ कुछ क्लासेस लेते रहेंगे, डाउट्स वगैरह आप पूछते रहिएगा। जैसे जैसे आपको डाउट्स आते जाए ना, उस तरह से आप हमको चैट में भेजते जाइए, ठीक है?
ठीक।
संडे के दिन हम टाइम निकाल के फिर आपको डाउट सारे ले लेंगे। अब खुद से तो आप पढ़ ही लेते हैं जनरली, डाउट्स वगैरह जनरली आपको पूछना रहता है ना, उसी तरह कीजिए, एंड देन वी कैन गेट सम क्लास ऑन संडे।
ओके।
इसमें कैसा रिजल्ट आया आपका? आप तो परेशान हो गए होंगे, हाफ ईयरली के बाद फिर से हाफ ईयरली देना पड़ रहा है आप।
नहीं, मैंने सिर्फ केमिस्ट्री का ही दिया था, केमिस्ट्री और इंग्लिश
अरे,
का।
अच्छा,
सारे
और
नहीं।
बाकी का नहीं दिया आपने, या फिर बाकी से पहले ही आप आ गए दुबई?
दोनों, मतलब
अच्छा अच्छा,
टीसी
देना
एग्जाम के बीच में मिल
देना
गया।
अच्छा अच्छा, देना भी नहीं था आपको बाकियों का?
नहीं।
अच्छा, तो कुछ रिजल्ट आया, कुछ पता है? या पता
अभी
कहाँ से चलेगा आपको?
अभी एग्जाम्स साइंस स्टूडेंट्स का हो गया, कॉमर्स एंड
अच्छा
इस वाले बच्चे टाइम लगेगा।
अच्छा अच्छा अच्छा, आपने वही ज़ैद की स्कूल, सेम, या फिर कहाँ है?
सर अलग है।
अलग है? ठीक है, नेक्स्ट देखिए, एक आयन का ले लेते हैं, NO2 नेगेटिव। ओके, सेकंड इज NO2 नेगेटिव। So start with total valence electron. कैलकुलेट किया था हमने, कितना बताइए?
NO2 है 80।
NO2 नेगेटिव 18 इलेक्ट्रॉन्स, राइट? स्केलेटन बनाएंगे सिंपल, ऑक्सीजन, 1 बॉन्ड, नाइट्रोजन, ऑक्सीजन। टोटल वैलेंस इलेक्ट्रॉन इज 18। यूज इज हाउ मच?
हाँ बस एक
कितना यूज हुआ है इन
यूज
द
है
स्केलेटन?
4।
हाँ 4, वेरी गुड। रिमेनिंग इज
14।
14, ठीक है। स्टार्ट करते हैं। सबसे पहले कहाँ डालेंगे हम ऑक्सीजन में? ठीक है, तो 1 2 3 4 5 6। ऑक्सीजन खुश है, अगले ऑक्सीजन पे जाते हैं। अभी हमारे पास कितने बचे हुए? 8 बचे हुए, है ना? 1 2 3 4 5 6, डाल दिया 8 हमने, सही है। 2 बच गए अब, है ना? 2 बच
हाँ
रहे हैं ना?
जी।
2 बचते हैं अब ऑक्सीजन पे तो डाल नहीं सकते ना, बिकॉज 8 डाल दिए हैं हमने, है ना? 8 मतलब इन सेंस 6 डाले हैं, और ये 2 इलेक्ट्रॉन इसके पास पहले से ही, तो ऑक्सीजन इज हैप्पी, सो आई कैन नॉट ऐड मोर इलेक्ट्रॉन। अब डालेंगे नाइट्रोजन में 2 इलेक्ट्रॉन ऐसे, ठीक है?
सर एक ऊपर एक नीचे नहीं होगा, सिमेट्री है।
नहीं, ये पेयर में आएगा ना, 2 इलेक्ट्रॉन जब आ जाएगा तो इस तरह से, ठीक है? यहाँ पे you will have it in still it is symmetrical, see?
ओके।
Okay, now you ask, ये ऑप्शन खुश है, happy?
यस।
How many electrons? 8 electrons. This oxygen, 8 electrons. What about this nitrogen? How many electrons can you see?
6।
6 electrons, ठीक है? Now one of the oxygen is going to share, they have to share, तो एक ऑक्सीजन इसको शेयर कर देगा इलेक्ट्रॉन एंड इट इज गोइंग टू हैव अ डबल बॉन्ड देयर. नाइट्रोजन, सॉरी, oxygen, double bond nitrogen, single bond oxygen. This oxygen is going to have only 2 lone pair. This is going to have, nitrogen is going to have 1 lone pair. This oxygen is going to have 3 lone pairs. So bond pair, it is equal to how much? 3. Lone pair of electron is equal to how much? 1, 2, 3, 4, 5, 6. Okay, and then one thing you have to do is, देखिए हमने अभी तक चार्ज इसको डाल देंगे, ठीक है, बिकॉज इट इज NO2 नेगेटिव, राइट. ये स्क्वायर प्लीज मत बनाइएगा, हम बस वो स्क्वायर ब्रैकेट बनाने के लिए इसको बनाते हैं. ठीक है, and then you will put a negative charge here. This is NO2 negative Lewis dot structure.
So नेगेटिव क्यों डालेंगे हम जब हमने टोटल नंबर ऑफ इलेक्ट्रॉन्स को 18 कर दिया
है?
अच्छा नहीं,
मतलब चार्ज तो है ना उसमें, नेगेटिव चार्ज तो है ना. ठीक है, सो बस इसको याद रखिए आप. 8 total valence electron, skeleton, then complete the octet. Make each and everything happy, starting with the surrounding atoms, and then if the central atom is not happy, share some electron from surrounding atom, making multiple bonds. Okay, so we'll discuss a bit more in the next class. कुछ हम आपको homework भी दे देंगे, ठीक है. And I think ये लोवेस्ट डॉट स्ट्रक्चर का तो यहाँ पे ये खत्म हो जाएगा कि उसकी ये क्या है. देन वी कैन स्टार्ट विद द टाइप, लाइक टाइप्स ऑफ केमिकल बॉन्ड. जो वैलेंस बॉन्ड थ्योरी है उसको हम लोग पढ़ना चालू करेंगे. ओवरलैपिंग, दो सिग्मा बॉन्ड, पाई बॉन्ड वगैरह है, ठीक है. चलिए, थैंक यू गाइस. आई थिंक यू